Hello and welcome to Virtual Learning Network. This e-lecture is on Computer Basics and PC Software, Block 2, Unit 1, Introduction to Software Evolution. The topics we are going to cover are Introduction, what is software, software evolution, evolution of software architecture, mainframe architecture, file sharing architecture, client server architecture, cloud computing, evolution of software design paradigm, non structured design paradigm, structured and modular design paradigm, object oriented design paradigm, component based paradigm, service oriented paradigm, evolution of programming languages, procedural language, object oriented language, evolution of software licensing, introduction to software licensing, type of software licensing, type of software, system software, programming software, application software, utility software, preserved software, open source software. Last one is summary. Let's start with introduction. This enables a computer to perform all the useful and desired functions. Different type of software help a computer to be used for multiple or varied purposes in totally different areas of work. What is software? A computer system consists of two parts, hardware and software. The first part, computer hardware, refers to all the visible components of the computer software such as keyboard, monitor, hard disk, printer, scanner, processing unit, memory, electrical connections, etc. The second part is a set of a simple and step-by-step sequence of instruction that tells the hardware what to do and how to do it. This organized set of instructions written in a defined order and to accomplish a specific task is called computer software or computer program. This diagram shows the relationship between computer hardware and software. Software evolution. Over the decades, computers have been used in new areas and to solve new problems. With challenging needs and improved hardware, the software has evolved in its various aspects. The software architecture, its design paradigms, programming languages, its usage, costing, and licensing have all changed and evolved over the years. Software evaluation with respect to its architecture, design paradigm, programming language, and licensing will be covered in the next slides. Evaluation of software architecture. The software architecture has always moved in unison with the hardware advancement. Mainframe architecture, file sharing architecture, client server architecture, internet based architecture. Let's start with mainframe architecture. An architecture is a set of defined terms and rules that are used as instructions to build products. Each generation of mainframe computer has included improvements in architecture while remaining the most stable, secure, and compatible of all computing platforms. Mainframe computers remain the most stable, secure, and compatible of all computing platforms. The latest models can handle the most advanced and demanding customer workloads. File sharing architecture. In this architecture, resources could be added as and when necessary or desired. Thus, it provided a low-cost entry point with flexible arrangement. The drawbacks was that application logic was executed on the client server, typically provided files to store data. It worked fine as long as the volume of data transfer was low and shared usage and content update was low. Client-server architecture. In client-server architecture, the tasks or workloads are partitioned as server programs, which is providers of a resource or service. Client-server architecture. In client-server architecture, the tasks or workloads are partitioned as server programs, which is providers of a resource or service. Client programs, which is requester of resource or service. Client and servers may reside in the same machine, or they typically reside in separate pieces of hardware and communicate over a computer network. A server machine is a host that runs one or more server programs which share their resource with clients. A client does not share any of its resources but requests a server function or service. The server program fulfills the client request. Clients initiate a communication session with the server. The client server system may be 2-tiered, 3-tiered, or n-tiered. The client server system 2-tier is 2-tier architecture. This approach basically introduces a database server to replace the file server. The emergence of relational database management system and graphical user interface applications lead to database server, which could be accessed through the GUI based client applications. Since the client query the database over the network and only the relevant data is supplied to the client, the network traffic is greatly reduced in comparison to the file server system. This diagram shows 3-tiered client-server architecture. A new generation of client-server implementation takes a step further and adds a middle tier in between client and server to achieve 3-tier architecture. This leads to enhanced network performance and improved extensibility of business systems. 3-tier methodology lacks some critical features such as reusability of application, logic code, and scalability. N-tier architecture. The 3-tier architecture can be extended to n-tier when the middle tier provides connection to various types of services, integrating and coupling them to the client and to each other. Partitioning the application logic among various hosts can also create an n-tiered system. Internet-based architecture. The user accesses the web servers through the web browsers on the client machines and over the network. This leads to very thin client-based applications which reside on corporate web servers. The advantage of web-based applications is that they do not have to be tailored to run on specific platforms. But since the web application cannot perform client-side processing, they limit the user experience by turning the client computers into dumb terminals. Webmails, online transactions are examples of web applications. Cloud computing. Cloud-based software services typically mean that the consumer does not own the hardware and software but still gets the desired service. It is an IT delivery model that offers large-scale shared infrastructure and computing resources as a service through self-service pay-per-use access. Through it, leverages recently developed technology. Cloud computing is a business, not a technical trend. Key features of cloud computing are infrastructure sharing, self-service, pay-per-use, etc. Evaluation of software design paradigm. A non-structured program usually consists of sequentially ordered statements, usually one in each line. There is no concept of procedures in non-structured program. Hence, there are no independent reusable units in this programming paradigm. Structure and modular design paradigm. Structure design paradigm introduced the concept of selection and repetition of statements in code. Execution along with the line by line execution. It allowed writing of procedures and functions. These are the terms used for a block of code that is written to perform a single task. Procedures and functions were the beginning of compartmentalization and hence reusability of program code. Procedures and functions which were for similar purpose were grouped together to get a module. A big software application consisted of multiple modules, each performing a particular task. Object oriented design paradigm. Object oriented design is built on the premise that programming problems can be modeled in terms of the objects in the problem domain. In this design, any object of interest in the real world is an object in the program code. This helps to effectively model the real world and interactions of items within it. As the objects in the real world interact with each other, similarly, the objects in the program interact through their interfaces or messages, which are very well defined and contained in the objects. An object exposes the interface that can be called on by other objects that need the object's functionality. Because an object is a self-contained entity and because its interface is well defined, it is highly reusable across many applications. For example, schools and student are objects in real world. They would be considered as object in object oriented design also, and they would interact with each other through messages. Component based paradigm. The components of object oriented paradigm were extended to component based programming. Component based development was many concepts to object oriented methods. It gives a more abstract view of software systems than object-oriented method. The meaning of component or component-based programming is initiative programs are broken down into primitive building blocks which may be flexibly plugged together according to well-defined protocols. The idea behind component-based programming is to develop software system by assembling a set of independently developed components. Service-oriented paradigm. Service-oriented programming builds on object-oriented programming, adding the premise that problems can be modeled in terms of the services that an object provides or uses. A service is a unit of functionality defined by a set of message exchanges that are expressed using an implementation neutral grammar. It is a behavior that can be implemented or provided by any component for use by any component based on message exchange. Evolution of programming languages. Has the software architecture moved from mainframes to internet-based and design paradigm evolved from known structure to service-oriented programming languages evolves to support the architecture and the design paradigm. First one in procedural language. Procedural programming could also be called linear programming as one thing happens and then the next. Each instruction is executing in order from the top of the file to the bottom. It focuses on the idea that all algorithms are executed with functions and data that the programmer has access to and is able to change. Some languages which support procedural programming are C, Fortran, VB, etc. Object-oriented language. Object-oriented programming is more abstract than procedural programming because It looks for pattern and reusability. The same code can be loaded and executed many times to accomplish a task without having to retype it. There are the three main concepts that any language needs to support to be an object oriented. First one is encapsulation. It is a mechanism through which a protective wrapper is created to hide the implementation details of the object, and the only thing that remain externally visible is the interface of the object. Encapsulation prevents code and data from being arbitrarily accessed by other code defined outside the wrapper. Inheritance. It is the process by which a new class is created using an existing class. It is a way to compartmentalize and reuse code since it allows classes to inherit commonly used state and behavior from other classes. The new classes are called the derived class and the main class is called the parent class. Polymorphism. Polymorphism is the characteristics of being able to assign a different meaning specifically to allow an entity such as a variable, a function or an object to have more than one form. It is the ability to process object differently depending on their data types and to redefine methods for derived class. Evaluation of software licensing. Software licensing has kept pace with the evolution of software solution offered by the vendor or the solution provider community. Introduction to software licensing. Software licensing, which govern the usage and redistribution of software. Type of software licensing. First one is individual license. It allows you to install the software only on a single standalone machine. Next one is open source license. It grants you the right to freely modify and redistribute the software. Next one is commercial license. These are mostly for the large enterprises that use software for commercial purposes. Type of software. Computer software can be broadly classified as system software, programming software, application software. Let's start with system software. System software helps run the computer hardware and system. It is designed to control the operations of a computer and coordinate all external devices like communication devices, printers, keyboards, display units, etc. It manages all the computer resources like memory and processor time in optimal and stable manner. Some common type of system software are operating systems, server programs, device drivers, communication software. Explanation of system software. Let's start with operating system. Operating system is the software that manages all the computer's resources to optimize its performance, provides common services for efficient execution of various application software, and act as an interpreter between the hardware, application programs, and the user. An operating system is essential for any computer to be useful to us. When a user or a computer wants the hardware to do something, the request is always communicated to and proceeds by the operating system. Operating systems perform basic tasks such as recognizing input from the keyboard, sending output to the display screen, keeping track of files and directories on the disk, and controlling peripheral devices. Server programs. Server programs are dedicated computer programs that run as services and serve the needs or requests of other programs. These services may run on a dedicated hardware or on the same computer as the requesting program. Also, One or more services may run on the same computer hardware. Some common example of different type of server programs are web server for hosting websites, print server manage multiple print requests for multiple printers, etc. Device drivers. Device drivers are shared computer programs that provide an interface between the hardware device and operating system or other higher level programs. Device drivers are hardware dependent and operating system specific. They allow you to add and remove devices conveniently from your computer system without changing any of the applications using that device. Communication software. In a networked environment, the communication software or network operating system allows computers to communicate with each other. It enables sharing and transferring of data across the network. It controls network operations and manages network security. Programming software. Programming software usually provides tools to assist the programmer in writing computer programs and software using different programming languages in a more convenient way. Programming software includes, first one is compilers. A compiler is a program that translates the code written in a high level programming language to the code in low level language. The compiler translates each source code instruction into a set of rather than one object code instruction. Generally, the object code is the machine language code. When a compiler compiles a program, the source program does not get executed during the process. It only gets converted to the form that can be executed by the computer. Debuggers. A debugger or debugging tool is a computer program that is used to test and debug other programs. Typically, debuggers offer functions such as running a program step by step or breaking at some event or specified instruction by means of a breakpoint and tracking the values of some variables. Interpreter. Interpreter is another translation program. It takes the source code instruction one at a time, translates and executes. Linkers. A linker or link editor is a program that takes one or more object file codes generated by a compiler and combine them into a single executable program. When large software involving many programmers is to be developed, then the modular approach is adopted. The software is divided into functional modules and separate source programs are written for each module. Each of these source files can then be compiled independent of each other to create a corresponding object file. Eventually, linker is used to combine all the object files and convert them into a final executable program. Last one is text editor. Text editor is a type of a program used for adding plain text files. Many text editors for software developers include source code syntax, highlighting and automating completion to make program easier to read and write. Common text editors in Windows environment are Notepad and TextPad. Application software. Application software is designed and developed to accomplish one or more specific tasks or solve a particular program. Application software may be for commercial or scientific use. There is wide range of application software available for varied purpose. Some major category of these applications include word processing software, spreadsheet software, database software, presentation software, graphics software. Utility software. Utility programs help manage, maintain and control computer resources. These programs are available to help you when the day-to-day chores associated with personal computer and to keep your system running at peak performance. Some of utility programs are given below: antivirus software, backup utilities, diagnostic programs. Preserve software. It is a type of software that is designed to secretly access a computer system without the owner's consent and damage the system. Some of preserved software are given below: computer virus, computer worm, Trojan horse, rootkits. Open source software. Open source software is software that comes with source code and importantly also provides right to study, change and improve the software. This development happen in a large collaborative environment without any direct objective of the software's commercial success. Primary objective of the open source movement are as following: reduce the software cost, improve quality and security, avoid forced lock into vendor priority software. Summary time. In this unit, we studied how software evolved over the years. Software grew in its size, usage, complexity, development techniques, design, and architecture. In the early days, software was developed for large centralized system. It was generally bundled with the hardware since the cost of software was negligible in comparison to the hardware. The source code was easily available for modification, improvement, and redistribution. As the hardware developed, machine became smaller yet much more powerful. Computer system usage and software complexity increased considerably. Higher complexity resulted in higher software cost. Thank you for this session.